Okay, now I want to show you another example, we'll call this example 2, which is similar to question 3, which is at the end of lab this week. One thing I should note at this point is there are multiple ways to get the correct answer. So if you don't do it this way, and as long as you get the right answer, then you should do it the way that makes most sense to you, because there are a couple of different ways to get to the correct answer. But I'll show you the way I would approach something like this. So let's, for example, have a solution. We're going to have 8 milliliters, and we have the concentration of 4 nanograms per milliliter. We're going to take 1.5 milliliters out of this and put it into a new tube. So we want this new concentration to be 2.5 nanograms per milliliter. So what we need to know is what is the final volume. So we're going to have a final volume which will take the 1.5, add some volume of dilutant, and will give us the concentration that we're looking for, which is 2.5 nanograms per milliliter. So as I said, there's multiple ways to do this. My recommendation personally is to use the sort of stoichiometry type approach, which is C1V1 equals C2V2. And if you think back to rearranging the equation, because there's no loss in mass, C1V1 equals mass, and then the mass will also equal C2V2, so that's how that works. So the challenge with this, is identifying the correct C1s and V1s, and C1, V1, C2, V2 to correctly do it. And it's easy to get tripped up on this. So let's set this up. So we have C1, V1 equals C2, V2. So let's see which numbers we know. So the first thing we know is C1. The concentration of 1 is going to be 4 nanograms per milliliter. So I'm going to put 4 in here. And then we're going to multiply this by volume 1. So this is where we have to be very careful. So volume 1 is in fact not the 8 milliliters. It's actually the transferred volume. This is irrelevant. This could be 8 milliliters, it could be a gallon. It's not relevant to this. It's purely this number, this transferred number here, which is important. So I'm going to multiply that by 1.5. Okay, so now what we want to do is look at the other part. So we know what we want C2 to be. C2, we've determined we want the final concentration to be 2.5 nanograms per milliliter. So 2.5. What we don't know is V2. We don't know what this volume is. We know part of V2 is going to consist of 1.5, but we don't know what kind of dilutant we're going to add. So we can rearrange this very easily. So we have V2 equals, and then we're going to have 4 times 1.5 divided by 2.5. And if my math's okay, we're going to get 6 divided by 2.5, and that is going to give us 2.4 milliliters. So our V2 is going to be 2.4 milliliters. But remember, this 2.4 also comprises this 1.5. So we have to subtract that 1.5 to know the dilutant. So it's 2.4 minus 1.5, and that gives us 0.9 milliliters of dilutant. And as I say, it's always good to make sure this makes sense. Does 0.9 milliliters sound sensible? Well, if you think we are going from a concentration of 4 nanograms per milliliter down to about 2.5 or we're going down to 2.5 nanograms per milliliter. So it's almost a 1 in 2 dilution. It's almost half. Not quite, but almost. So it makes sense if you're taking 1.5 milliliters, it's going to be almost half, but a little bit less. So if you transfer 1.5 and 0.9, that sounds like it's in the right ballpark, right? If you're doing a 1 in 2 dilution, but it's slightly more, then you'd expect the amount of dilution to be similar, but a little bit less. So again, it's always worth just double checking, does this make sense? And that can quickly identify whether something has gone wrong.